So, good evening, everyone. Welcome to the third live interactive session for the course Nanotechnology in Agriculture. My name is Amit Dukle. I am Prime Minister Research Fellow in the Department of Mechanical Engineering, IIT Tirupati. The course instructor for this course is Professor Mainak Das, professor in the Department of Biological Sciences and Engineering, BSP, IIT Kanpur. Uh, the course code is NOC 25BT1. So this is the third live interactive session. I welcome you to the session. So before we begin, like always, some formality which is just for everyone. So this live interactive session is to boost your performance. We will solve some previous year questions so as to help you solve this year's assignment and also help you in the exam. This is not compulsory, but we highly encourage you to join the sessions. Be respectful in the chat. Questions can be asked at the end of the session or by unmuting yourself. So again, like this, like previous week, this time the assignment is very easy. So we'll be done very soon. So you can ask your question when the assignment is going on, or else you can ask later also. So today we'll discuss previous year assignment and then we'll move to the question and answer session. So Sorry for the inconvenience. There's some problem with the campus network. I'll just start resharing. So yeah, so sorry for the inconvenience. We'll start. This is the session plan. So we'll be discussing the practice assignment 3, and then we'll be moving to the question and answer session. Um, so the this is a course outline. This is a 8-week course. We are in the week 3. So the content for this week is application of nanotechnology in modern day agriculture practices. The first part of this course. So without much ado, we will just start with the week 3 practice assignment. The first question is dash is a process applied to the synthesis of ultra thin films and surface coating. The options are Langmuir Blodgett film formations, SAM preparation, that is self-assisted, self-assembled monolayer preparation, physical vapor deposition, or air fry. So, any guesses?
The PVD.
Yes, the answer is PVD, physical vapor deposition. So I'll just show you how the courses, how all the processes are. So air fry, obviously, it's just a wrong option. So in the first thing, Langmuir blooded film formation. Basically, this is the how the figure looks like. So you'll have water. You will put the amphiphilic liquid over the water surface, and then you will just pull the surface, and that layer of amphiphilic liquid will be formed on the Langmuir blood, that will be formed on the surface, and that is called a Langmuir blooded film. Then this is a self-assembled monolayer. So basically, this is something like spin coating. In those kind of applications, this is used. Basically, the resin is dropped, and then through the through rotation, basically the monolayer spreads over the surface. But in both the cases, you will only get a monolayer. You will not get a ultra thin film. So for that, you have to use the physical vapor deposition. That is this process given on the right hand side. So as we discussed last time also, it happens in a inert argon gas atmosphere. The argon is charged. The charged argon hits the substrate that is at the top sputtering target. The argon ions will go and hit the sputtering target, that will eject the sputtering ions. So that will be like gold ions or copper ions that will be ejected from the top, and then they will go and hit at the bottom where the silicon substrate is kept, and you will get a thin film. So I hope the all the three processes are known, are also understood by you. Air fry is a just a like it's a fake option. So any questions? If not, we'll move to the next question. So this is the second question. Ball milling is a dash process to fabricate nanomaterials. Mechanical method, chemical method, biological method, mechanobiological process. So uh, we all know, like from the names we can understand. So mechanical method basically uses mechanical energy for making the nanomaterial. So that is basically a top down method. You will have something big, and then you will be crushing it or breaking it down into getting the nanoparticle. The chemical method basically uses chemicals, so it will be Sol-Gel method or co-precipitation method, or those kinds of methods, hydrothermal methods. Biological method basically use biological, so it uses bacteria as the for fabricating, for synthesis of nanomaterials. This field is gaining a lot of significance nowadays. So mechanobiological process, basically you subject um, the biological uh, uh, what do you say source under specific stresses, so as they develop or they give out um, the nano material. So that is how the things work. So in this case, so I'll just give you a hint. Ball milling is basically you have a bowl. In that you will have like the balls of them. They can be steel balls or tungsten ball or zirconia balls, and then you will have your material that is used, and so then it will just break down everything by impact and attrition. So there will be impact that will happen, and that will just break down everything. So what kind of method do you think it is? So is it a mechanical method, chemical method, or um, well, yes, so the answer is mechanical method. It basically breaks down everything. So basically, when you are going from top to bottom, when you are breaking it down using mechanical force, it is called as the mechanical method. So the answer is mechanical method. Um, any questions? I think so. It's a very simple question. So we move to the third question. So yeah, this one you need to like think a bit. The disadvantage of ball milling method include rise of contamination occurs from wear and tear of in the ball collision. It causes an increase in the machine noise when the concealed cylinder is made of metal and is reduced when the cylinder is made up of rubber. It is a time-consuming process. Only correct choose the correct options. Only statement one and two are correct. Statements one, two, and three are correct. Only statement three is correct. Only statement one is correct. So what do you think is the ball is the disadvantage? So in the ball milling process, as I said earlier, you will have uh, um, uh, a bowl. It will be a steel bowl, or it should be like in that you have balls. So you in one bowl you put another bowl, you put a ball. So what can be made of steel? It can be made of zirconia. Hello, is it audible now? So yeah, so I'll just restart with the explanation of the ball milling process. So this is the question here. So ball milling process is basically used for develop for it has two applications. One is for mixing, and the other is for nanoparticle fabrication. So basically, there will be a ball mill. It is the most commonly used ball mill is basically a plenary ball mill. So in that ball mill, there will be a bowl. it can be a hardened steel bowl, it can be a rubber bowl, it can be a Teflon bowl. Depending on what you are doing, you will have a bowl. Then you will have, in the bowl you will put the material. So if you are putting a raw material, so if you are putting 100 grams of raw material, you have to put, there is something called as loading ratio. So basically, if you are putting 100 grams of raw material, you will have to get you will have to use at least 1 kg of ball or 1.5 kg of ball. So that is called as the loading ratio. So once the loading ratio is met, the bowl is sealed, and depending on that application. So if the material you are crushing might need a inert atmosphere, even inert gas is also supplied through the ball mill. So that is also done during the process. And once the entire chamber is sealed, it is basically allowed to rotate at a very high speed. So what happens is the balls hit the balls of the bowl. So balls, the tungsten ball will hit the balls of the rubber bowl. Like I'm just giving an example, and then there'll be impact, and that the impact that causes the kinetic energy basically leads to the material breaking down. So there'll be a lot of impacts hitting. There'll be impact and attrition. So the mechanism is called as impact and attrition. So there'll be a lot of impact between the bolts ball and the material, and then you will get the crushed powder. So that is how the entire process works. So you can use any ball. The thing is, it has to be like the balls, if you are using, the balls have to be harder than the material which you are crushing. In case of bowl or the container, we could say, since there is a lot of problems in pronunciation. So the container which you are using has to be, you can use anything. So you can use Teflon if there is a chance of reaction between the material you are using and the container. So you can use Teflon also, you can use rubber also. But the problem is, if you use a rubber or Teflon, they absorb the energy. So there is a energy absorbed, the kinetic energy that the ball will be undergoing will be absorbed by the walls of the container. So that is something which you have to keep in mind when you are doing ball milling. So what do you think, which of the statements here are correct? So there is a rise in contamination occurs from wear and tear of the ball in ball collision. It causes an increase in the machine noise when the concealed cylinder is made up of metal, and is reduced when the cylinder is made of rubber. It is a time consuming process. So what do you think will be the right answer? Only statement 1 and 2 are correct. Statement 1, 2, and 3 are correct. Only statement 3 is correct. Only statement 1 is correct. So the answer is B. All the three statements are correct. So because you can, as I explained to you, there is a lot of collision that is happening between the balls. Obviously, there will be a wear and tear. So there is a rise in contamination due to ball collision. It is also a very slow process. It takes a lot of time. Since you are breaking down something very big into a nanoparticle, it will take a lot of time. And again, since there is a collision that is happening, in case of metal, if the container is also made up of metal, there will be a lot of sound that will be generated. In case of rubber, the sound will be less, but again the efficiency also will be less, because rubber will absorb the energy. So you have to make the trade off. You have to, there is a lot of things that goes into the container. So time consuming process, basically most of the nanomaterials fabric like synthesis processes are time consuming, other than the laser based processes. So laser based processes are the only faster ones. Other processes actually take time. So even if you go for co-precipitation method or Sol-Gel method, or most of the methods, it will take time. So time consuming processes basically in all the nanoparticle synthesis processes, time consuming will happen. So we move to the next question. PVD process is carried in a vacuum held in vacuum chamber about 10 raised to minus 6 torr from a anode arc source, graphitic arc source, tungsten arc source, cathodic arc source. So this is basically a very like there is nothing to understand. This is something which you need to know. So this is how a vacuum source looks like. So you will have the rotations, and there'll be holders, substrate holders, and this is how actually the vacuum source looks like. So basically the gas comes from one end, and yeah, the vacuum is generated here, and this is how it looks like. So the answer is cathodic arc source uh, for this question. So this, it's a like information, you should know the information kind of question. So moving to the next question. Nanosheets and nanoplates are the examples of 3D nanomaterials, 2D nanomaterials, 1D nanomaterials, 4D nanomaterials. So we have discussed this a lot in the last section as well, last two sessions as well. So any guesses?
Really?
No, it is a 2D nanomaterial. So as I said last time, uh, it's a 2D nanomaterial. So basically, when one dimension is when all the three dimensions are in the nanoscale, it is called as a 0D nanomaterial. When one dimension is more than the nanoscale, it becomes a 1D nanomaterial, that is nanowires or nanotubes. When two dimensions are more than the nanoscale, so in this case of nanosheets or nanoplates, it becomes a 2D nanomaterial. And then if all the three dimensions are outside the nanoscale, it becomes a 3D nanomaterial. So basically it will be a compound or like you make a composite basically by mixing or adding nanotubes and nanowires or nanosheets. You are making them over making an assembly out of it. So that is called as nanostructures basically. That is called as 3D nanomaterials. So these are a few examples of 2D nanomaterials basically. This is how 2D nanomaterials actually look like. So any questions? So we'll move to the next question. Dash is a process used in the printing that involves substrate covered with the stamp dipped in ink to get an image. Lithography, photography, photoacoustic lithography, luminography. So lithography is one of the oldest process in printing. So basically it is derived from the Greek word lithos, which is stone, and graphy is printing. So basically it's a very old process. Photography basically everyone knows. It is used very widely. Photoacoustic lithography is basically you use photo and sound, light and sound basically, to do the lithography. So basically, it's a very complicated kind of process. In that you are using sound waves and the and light waves. So basically, to do the lithography. And luminography again, it's a basically it's depends on light. It uses a light source. So what do you think will be the answer? Um, any guesses? Yes, we have a right answer here. Yes, the answer is A, lithography. So this is how the process looks like. So you have the substrate, on that you deposit a film. So maybe that will be a photoresist basically, and then you pass light through it, so that or you can use a stamp basically. In photolithography, you pass light through it. In normal original lithography, you use the stamp to actually do the printing. So on the substrate, then you get the structure, and that is how the entire thing looks like. So The answer here is lithography. Uh, so the next question is basically dash are made up of semiconductor nanoparticles and are lumi, luminescent. So that is basically they emit light. The 1D materials, 2D materials, quantum dot probes, 3D probes. Any guesses? Yes, so basically the answer is quantum dot. So basically, depending on the size of quantum dots, see, here you can see a Wollstonite quantum dots basically. So you can see when you have a smaller size of Wollstonite quantum dots, you will have blue color. When you are going at a, like you can see from here, if the size is increasing, the color is becoming green, and when the size is the highest, the size becomes red. So basically you can tailor the quantum dots, and based on their size you will get a different luminescent properties from the quantum dots. So basically that is how what they are used for. So the answer is quantum dot probes. uh, so we move to the next question. Chemical co-precipitation method involves mixing two different salts with precipitation in an aqueous solvent, especially an acid, base, inert gas, metamaterials. So it's a very simple thing. Any guesses? So co-precipitation method is basically we are using two metals also. If you want to make per se a uh, uh, we'll say magnetic nanoparticles of iron. So what will happen is first you will use ferric 3 chloride and ferrous chloride. So basically you will use both the iron salts. You will dissolve them in a solvent, and then you'll mix them. So you'll mix them very in such a way that the molecules break and then they come together and form, they bind to each other, and then you will use some precipitating agent so as to precipitate it. So you'll filter out the supernatant, and whatever you get as a precipitate, that is your nanoparticle. So that is how the entire process looks like. So what medium do you think will be used in this process? um, so the solvent is usually a base. So here this is one of the example. So in this you are making a solution, so then you are adding ammonia. Basically you are using the two salts, you are having the entire uh, um, this is basically a process for getting magnetic nanoparticles. So basically you are putting the two salts, you are using water, and you are using oleic acid so as to slow down the process. So basically if you use something very strong acids, if you use hydrochloric or acid or nitric acid, they will only go and react with the iron, so that will create a problem. So what you do is you add oleic acid so as to get the nanoparticle. So if you don't add oleic acid, then also it's fine, but you use oleic acid so that the process is slowed. You don't have to go it very fast. So then is when you add ammonia, and when you add ammonia is when the actual reaction goes forward, and then you basically um, do the final process. So that is how it looks like. So the answer here is B, basis. We'll move to the next question. The main difference between graphene oxide and reduced graphene oxide is based on the presence of dash and its conductivity. Surface carbon, surface nitrogen, surface calcium, surface oxygen. So this is the structure of graphene oxide. So basically from this graphene oxide you can actually see there is a lot of surface oxygen that is present in the graphene oxide material. So the that again, because of the presence of the oxygen, it has a lot of like problems, such as it has poor conductivity, and like that is why reduced graphene oxide is basically used. So the answer here is uh, surface oxygen. So we'll move to the next question. The synthesis of near infrared absorbed nanomaterial has emerged in biological applications since the biological tissues exhibit low absorbance in that region, high absorbance in that region, no absorbance in that region, extremely high absorbance in that region. So I'll just show you the absorbance spectrum of most of the tissues. So these are a few tissues, biological tissues that are there. So uh, where do you think is the like the absorbance spectrum you can see from this chart? So basically, from this you can see that the absorbance is low in the near infrared spectrum. Basically, that is why the biological applications, uh, low near absorbance based nanomaterials are used for that, because there is a low absorbance of the biological tissues in that region. Uh, so, if you any questions for Yeah, I will repeat 4 and 9. So yeah, we have been asked to. I've been asked to repeat question 4 and 9. I'll repeat that, and then just before we go to that, I just want to say something. If you have any questions regarding this year's assignment, and if you need any hints from my end, I have kept the assignment this year assignment open in the new session. Uh, yeah, so we'll go with previous year assignment and this year assignment also. So whatever you have problems with this year assignment, we'll go for with previous year assignment, we'll go first. And if you have questions with week 1 and 2 assignments, so week 3 assignments also, if you have any problem and if you need any hints, just keep your questions ready, and we'll first go through for uh, so, so a minute, we'll go one by one. First I will go to Sandipta Bera's query to answer question 4 and 9. So we'll go one by one. Rakshita Prasad will just go first go with Sandipta Bera's query. We'll finish this assignment and then we'll start with everything. So in the meanwhile, if you have any questions with this year assignment and everything, just keep your questions ready. Don't put them in the chat. I'll ask you when at that time you start putting in the chat. Okay. So we'll move to first to question number 4. So basically, this is a recall type of question. So there is not much has been given in this. There is nothing to explain this question, but I'll just tell you. So PVD process is carried in a vacuum held in a vacuum chamber. So basically, as I showed you, it will basically be held in an inert atmosphere chamber. It will be like argon atmosphere. It will be 10 raised to minus 6 torr. That will be the vacuum that has been created. So it is a very low pressure. The chamber. Then how will you generate that vacuum? So basically what it is asking is whether it will be anode arc source, graphitic arc source, tungsten arc source, or cathodic arc source. So basically this is a type of a recoil type of question. So the answer is cathodic arc source. Okay. Hope this is fine, and we'll move to question number 9. So in the ninth question, basically they are asking what is the difference between graphene oxide and The main difference between graphene oxide and the reduced graphene oxide is based on the presence of dash and its conductivity. So surface carbon, surface nitrogen, surface calcium, surface oxygen. So basically, it is asking is what is the what is present in the uh, in graphene oxide that is not present in a reduced graphene oxide. So to give an overview, this is how a graphene oxide structure looks like. So what you can see in the red is basically what differs from graphene oxide and reduced graphene oxide. So basically, in reduced graphene oxide, you will find no the absence of surface oxygen, whereas in graphene oxide, there is a presence of surface oxygen. So the answer here is presence of surface oxygen. When you remove the surface oxygen is when you start getting better conductivity. I hope I repeated your question 4 and 9. So now we'll take Rakshita Prakash question. So few questions regarding previous assignment. So this is assignment 1 or 2, ma'am. Can you just type it in the chat box, madam? Two. Okay. So I'll just open it in my another window and I'll just check, because so as not to have any. Madam, I could not find this question. What is the number of this question, madam? First week, right? Okay, sorry. I'll just check. In the meanwhile, please put your question numbers so that we can go through them. For assignment 1, whoever has any other question, doubt, please give out your questions, please. So this is question number 3. Nanotechnology is based on decreasing size, increase surface area to volume ratio, um, only A or only both A and B. So the answer is both A and B. I will uh, raise it in the. So the answer is so answer is both A and B. It is a wrong answer. Whichever whatever has been given here is wrong. We will. I will. You can put that in the discussion forum. I will also put that in the discussion forum. But your doubt is valid. The answer is D, both A and B. Anyone has any other questions? It will be beneficial if all of you put that question in the discussion forum. Whatever problems you have, put those queries in the discussion forum. I will also put that, but you also put it so that there will be a more pressure. So we'll just finish this one, and then Debrata sir has raised his hand, so we'll just go there also. So we'll just finish this question. To use nanomaterials in agriculture is to be subjected to nano material treatment. Which part is subjected to nanomaterial treatment? Shoot, root, seed, shoot, leaves. So basically, this is a very weird question. Even I have not seen this question. So nan- materials. I don't think seeds will be the right answer. Uh, let me check. I have, since these questions I have not made them. Somebody else has made that. But yeah, these are really weird. This is a really weird question. But yeah, who thinks it should be seed? Like you can do in like root also, you can do it on the leaves also, you can do some nano pesticides, you can put on the leaves, you can put the nano fertilizer near the roots also. So basically it's a subjective question. I don't know how it has been put in the objective. So anyone thinks it should be seed only? Is there anyone who thinks uh, because I think it should be like it's a weird question only because you can use anything because in the leaves you can put nano pesticides. Yeah, in the roots you have nano fertilizer also. So without harming the soil, okay. So we need more clarity. Okay, so yeah, what Sir is saying also makes sense that if we do the treatment to the seed, there won't be any harm to the soil. But yeah, yeah, at the time of germination, that also makes sense. This is something which even I it is making me also think. So my guess would be leaves because nanopesticides are basically like they'll be not being used on they'll not cause any problems. Um, but yeah, we'll put this question in the discussion forum. I'll also put, you guys also put it. uh, Maybe if there is a lot of people having doubts, then they might cancel the question. So if there are too many people having doubts, just put that in the discussion forum. I'll also put that in the discussion forum so that it will be helpful. What Devrata sir is saying also makes sense. At the time of germination, it can uh, like it will not harm the soil. That also makes a lot of sense. But even using nanopesticides, it can be safer also. It will not actually lead to any uh, soil like it will not affect the soil health if it is like done properly. So that is also there. So we need to check properly. um, I I'll put this in the discussion forum. This question I think so I'll put and we'll try to get answer from sir only. Okay. Yeah. Yes, what sir is saying makes sense. You can put the seed overnight in the water using nanomaterial. But sir, it is like uh, that can help in the germination process. But you when you are looking at the long term entire plant cycle, you need fertilizer. Even if you put any nanomaterial in the seed in the beginning, that may help speed up the germination process. But the entire plant life cycle, if we want to use the nanomaterial, we can use it in um, on the leaves also in without harming the soil health. So we need to get more clarity on this thing. So I'll also put this in the discussion forum. Maybe this question we'll keep as a doubt question. So we have got one more question, that is the eighth question of the first week. So rice is grown in the rabi season. Rice grown in Rabi season is to be used as seed grain fodder. Rice cannot be grown in the Rabi season. Uh, so, what do you think should be the answer, madam? In this one, what do you think should be the answer, or what is your doubt basically in this? Rice is grown in the Rabi season, so that option is wrong. So, what is the doubt per se? Like with seed grain, uh, it is basically used for grain, but it can also be used as a fodder. So, what is your doubt basically? So basically, for Rabi, basically what has happened is rice is like mainly it is basically to confuse you and nothing else basically, because they wanted to get, see, there are very few questions which we can give basically. So when somebody is making these questions, obviously, yes, yes, that's what I was asking, because the answer they have given is right. Basically, this question was made to confuse you. Basically, rice is basically mainly. See, not all, everyone is from the agriculture background, so somebody will just think that rice is a kharif crop. So mainly, many people think rice is a kharif crop. So rabi is basically for wheat and those things. So that is many times. Even I used to think the same thing. So that is why when you go into deep, when I actually went through this syllabuses, when I actually came to know, because my background is mechanical engineering, my strong point is nanotechnology and not the agriculture part. So even I had the doubt, but when I went through it for this course, uh, I found out this that rice is grown in Rabi season as well. So this was just to confuse you. Maybe it was to just give you a confusion kind of form. So rice is basically used as a the grains are separated and it is used as a fodder for plants. Nowadays, even it is used for the preparation of bioethanol also. So that is one of the applications. So I okay. So in West Bengal, rice grows as seed for boro cultivation in the Rabi season. Um. Okay. Can you just so your answer is seed? Is are you saying your answer is seed? Debrata sir, are you saying your answer is seed in that case? If you have the doubts, no, we'll put that in the discussion forum again, because obviously when you are growing rice, it is for the grains. So the question is a bit confusing. Even I understand that it should be either seed, it should be either grain, it should be fodder also. So the last, you can say that the only last option is wrong, that it is not a thing. Yeah, I'm not changing any slide because we are discussing the assignment questions. So just a second, I'll just stop this, present something else, and we just go through. So can you see now what I'm sharing? Just a second. So yeah, so rice is grown in the rabi season to be used as seed, grain, fodder. Rice cannot be grown in rabi season. So basically, from this, actually, it can be used as a seed, it can be used as a grain, it can be used as a fodder also. But it is just the only the last option, that rice cannot be grown in rabi season, is is something which you can definitively eliminate. I'll put this in the discussion forum. You also guys put it in the discussion forum, so that we can do it. Yeah, temperature in the Rabi season is not appropriate for rice growth, but it is grown in 12 states. In Punjab, though, it is basically you have two or three crops of rice basically that is done, because there is a lot of plenty of water that is available in Punjab and those states, the Indus river states. So it is basically grown in two cycles, two crops of rice also. Even in Kerala, I think so, it is grown in two cycles. So um, Rabi rice, having rice in the Rabi season is very common. It's not very uncommon, basically. Mm. So, any other question, sir? You had actually raised your hand for some reason, so you can also put your query, or you can even unmute yourself and ask. Mm. Devrata sir, you had put your hand, you had raised your hand. So whatever your query is, you can unmute and ask, or you can put on input in the chat box. If anyone has any other question related to assignment 1 and 2, please let me know. So, yeah, sir has asked a very pertinent question. How will we get last year question paper? So the it is not very possible to get the answer paper, last year question paper, because even after the exam, even when you will be giving your exam this year, you will not be able to get the any question paper. So that is something which is very weird about this thing. So after the exam, you will get one form wherein you have to give all your queries, but you will not get to see the question paper again. So even in this exam, whenever you are giving, you, it is not possible to get the previous year question paper. But as a hint, I can tell you that it will be based on the previous year assignment. So lot of questions related to the assignments get repeated. I'm not saying all the questions get repeated, but many of the questions, like at least 15 to 20 questions, will get repeated from the previous year assignment. So whatever I'm doing, you can get at least the 20% of the previous year question paper is coming from the assignments which I am solving. So that is something which I can give you. So last year assignment, as I said every time, so where the videos are uploaded, so I'll just show it to you again. So now since we have the window open, so I'll just show it to you again. So just follow the screen. So this is the problem solving session. You go here. You click here. This Excel sheet is opening. So here you go. We have the PPTs of the session. So the in this you can get all the questions which we are solving. So you need not oh sorry, put I put wrong PPTs here. I'll get this sorted, but I think so. I put one wrong PPT here, but I'll get it sorted. I put the other course PPTs here, but I'll get this sorted. But by evening, you will get to access all the previous year assignment in the form of PPTs. So the PPTs of the sessions which we take here, they are the previous year assignment questions, and that you will be able to see basically. So So as I said, you can go through the PPTs. I'll be uploading this PPTs. I showed you how to upload it, how to access them. So from there you can do it. Yeah, yeah. So whoever has no other questions can please leave. If you have any questions related to assignment one and two, please list your questions here, and let me know. I will solve it today because we have time today. So which whoever has any questions, so we already had went through assignment one. Whoever has any other questions regarding to assignment one and two, please let me know. Else you are please free to leave. You don't waste your time here. We will not be discussing anything more as of now. Anyone assignment one and two? Any other questions? Please let me know. Okay. If you don't have any questions, you are free to leave. If you have any questions, please put your questions here uh, regarding to assignment one and two. So since people are joining now, we'll go through assignment this week's assignment questions again, and we'll also, in case you have any questions regarding the assignment one and two, you can also tell me the question numbers. So we just go through all the questions again once. Okay. So the first question is: Dash is a process applied for the synthesis of ultra thin films and surface coating. Langmuir blot-get film formation. ACM preparation, that is self-assembled monolayer preparation. Physical vapor deposition, PVD, or air fry. So basically, I'll just show you all the processes. So basically, air fry is a not a option, series option. So these are the series options. So basically, in Langmuir blooded film, so basically this is amphiphilic liquid is basically a layer of the amphiphilic liquid basically that doesn't get like that is immiscible with water is basically poured on a water surface, and then this the substrate is just pulled, so you will get a very thin single layer of the amphiphilic liquid on your substrate. In the second self-assembled monolayer process, what we'll do is we'll put the polymer on the substrate, and the substrate will undergo like rotation. So after you undergo all the rotation, you what you will get is you'll get a single layer, that is the self-assembled monolayer on the substrate. In the PVD process, basically you'll have a vacuum of argon. So basically the vacuum will be of argon, and then you'll put the argon gas that will be ionized, and that will hit the target. So you can see here this sputter target. So that argon will hit the sputter target, and that will eject. The what will happen is it will just go and it will eject the target atom. So basically, if it's a gold target, so argon will go and hit the target. Gold atoms will be ejected. The ejected gold atoms will be accelerated, and it will hit the substrate down at the bottom. The motion of the atoms, gold atoms, will be because of the potential difference. So from these three options, you can see that in the first two options, you can only get a single layer. You will not get a film. So the answer here is physical vapor deposition, (PVD). Okay. Uh, in the next question, ball milling is a dash process. Is dash to fabricate nanomaterials, mechanical method, chemical method, biological method, mechanobiological process. So basically, mechanical methods are basically they use mechanical energy to break down um, material into through mechanical force, like hitting it or crushing it, that kind of methods, and they break it down into a nanoparticle. In the chemical method, basically chemicals are used. So basically, you use a soldier method or a co-precipitation method. Those are chemical methods. Then the biological method are basically they use bacteria, and then there is mechanobiological processes. Basically, they use a combination of mechanical forces on the bacteria, and you get the output. So since ball milling is it involves mechanical force where you are crushing the material using so in the container you are putting the balls, and you are rotating the container, and then what you will get is basically mechanical action, that is impact and attrition. So ball milling, the mechanism name is impact and attrition. So it is basically a mechanical method. So moving to the third question, uh, the disadvantage of ball milling method includes the rise in contamination occurs from the wear and tear of the ball collision. It causes an increase in the machine noise. Um, when the concealed cylinder is made up of metal and is reduced when the cylinder is made up of rubber. It is a time consuming process. Only statement 1 and 2 are correct. Statement 1 and 3, 1, 2 and 3 are correct. Only statement 1 and 3 is correct, or only statement 1 is correct. So basically, it is a time consuming process because there is a lot of movement of the balls hitting each other. There is a wear and tear of the ball. And it also, because there is so much of hitting, if you are using a metal container there will be a noise. What will happen is, in case of a rubber container, rubber will absorb a lot of kinetic energy, so that will lead to less noise. So that is the option. So moving to the fourth question, physical vapor deposition is carried out in a vacuum held in the vacuum chamber around 10 raised to minus 6 torr from a anodic arc source, graphitic arc source, tungsten arc source, cathodic arc source. The answer is D, cathodic arc source. This is something which it is a fact-based question. There is nothing to explain. Um, Moving to the fifth question, nanosheets and nanoplates are examples of 3D nanomaterial, 2D nanomaterial, 1D nanomaterial, 4D nanomaterial. So basically, in nanosheets and nanoplates, there are two dimensions are more than the nanoscale. So they are called as 2D nanomaterials. Uh, so question six, dash is a process of printing that involves substrate covered with stamp dipped in ink to get an image. So for lithography, photography, photoacoustic lithography, luminography. So lithography is basically a very old technique. It is derived from the Greek word lithos, which means stone, and graphy means to print. So you are using a stone to print. Then there is photography, which we all know. Then there is photoacoustic lithography. So basically, you use light and sound waves to do the lithographic process. And then there is luminography that uses light. So the answer here is lithography. Use a stamp-like thing that is dipped in ink, and you get the image. So moving to the next question. Dash are made of semiconductor nanoparticles and are luminescent. 1D materials, 2D materials, uh, quantum dot probes, and 3D probes. So the answer is quantum dot probe. So you can see here, based on the size of the quantum dots, their luminescence properties changes. So the answer is quantum dot. So the next question, chemical co-precipitation method uh, involves mixing two different salts with precipitation in an aqueous solvent, especially acid, base, inert gas, metamaterial. So the answer here is a base, because you can see from this process. So basically, you use the two salts, and then you use ammonia, basically which is the base for stirring, and then you get the nanomaterial. Um, so
Yes.
the ninth question, basically, what is the main difference? So the main difference between graphene oxide and reduced graphene oxide is based on the presence of dash and its conductivity. Uh, I'll just mute. The main difference between graphene oxide and reduced graphene oxide is based in the presence of dash and its conductivity: surface carbon, surface nitrogen, surface calcium, and surface oxygen. So basically, you can see this is the difference between the reduced graphene oxide and graphene oxide. So on the graphene oxide, there is the you can see the red groups which are there on the graphene oxide. Basically, these are all oxygen groups. So there is a lot of surface oxygen in graphene oxide, which is not there in the reduced graphene oxide. Basically, you remove oxygen from graphene oxide is when you get the reduced graphene oxide. So the answer is surface oxygen. The next question is, synthesis of near infrared absorbed nanomaterial has emerged in biological applications since the biological tissue exhibit dash low absorbance in that region, high absorbance in the region, no absorbance in the region, extremely high absorbance in that region. So the answer is low absorbance in the region. So any questions related to this assignment, or any question related to assignment 1 and 2, you can just put in the chat, or else you can unmute yourself and ask.
In case you don't have any question, you are free to leave the session. So, for the sake of people who have joined now, we'll just go through all the questions which we discussed today. In case any questions, you can unmute yourself and ask. So, the first question: Dash is a process applied to the synthesis of ultra thin films and surface coatings. Langmuir blot jet for film formation. ACM preparation, that is self-assembled monolayer preparation, physical vapor deposition, and air fry. So these are how the processes look like. Um, can you mute yourself? Okay. Anyway, it's fine. So Langmuir blood jet process, basically you have an amphiphilic liquid on the water, and then you just pull the substrate up, and then you get a single layer basically on the substrate. In the self-assembled monolayer, basically you drop a polymer, and then you rotate the polymer on. Uh, then you rotate the substrate, basically it is like a spin coating, and then in the end you get a single layer monolayer of polymer on the substrate. In the PVD process, basically we have discussed it many times. So we have a vacuum chamber of argon gas. So argon is ionized. It goes and hits the sputter target. So that can be like gold, copper, anything like that. Then the argon gas will go and hit the target. Ions will be ejected, and the ions will go and get deposited on the substrate due to the potential difference. So as you can see in the other two processes, you can only get you can get only a single layer. You cannot get a thin film, or you cannot get surface coating. So for that, you need physical vapor deposition only. In the next question, so ball milling is a dash method to fabricate nanomaterials. Mechanical method, chemical method, biological method, mechanobiological method. So mechanical method basically uses mechanical energy, that is uh, uses mechanical energy to crush the material into small nanoparticles. In the chemical method, you use salts. You use like it's a soldier process, or the um, co-precipitation methods. In the biological method, you use something biological organisms like bacteria to fabricate nanomaterials. So the answer here is mechanical method. In the third question, the disadvantage of ball milling method includes the rise of contamination oc- occurs from wear and tear of the ball collision. It causes an increase in the machine noise when the concealed cylinder is made of metal, and is reduced when the cylinder is made up of rubber. It is a time consuming process. So you have to choose whether the statement 1 and 2 is right, whether all the statements are right, and whether only statement 3 is right, or whether only statement 1 is right. So the answer is all statement 1, 2, and 3 are correct. So the fourth question, basically, PVD process is carried out in a vacuum held in vacuum chamber of about 10 raised to minus 6 torr from a dash source. So anode arc source, graphitic arc source, tungsten arc source, cathodic arc source. The answer is cathodic arc source, because this is basically an information based question. There is no logic in it. Again, the fifth question, we have done this multiple times. Nanosheets and nanoplates are example of dash. 2D 3D nanomaterial, 2D nanomaterial, 1D nanomaterial, and 4D nanomaterial. So basically, there are four types of nanomaterial: 0D, 1D, 2D, and 3D. 0D nanomaterials, all the dimension are in the nanoscale. 1D nanomaterial, one dimension is more than the nanoscale. In 2D nanomaterials, two dimensions are more than the nanoscale, and in the 3D nanomaterials, three dimensions are more than the nanoscale. Yeah, so since in nanoplates and nanosheets, it's two dimensions are more than the nanoscale, we get call them 2D nanomaterials. Dash is a process used in printing that involves a substrate covered with stamp dipped in ink to get the image. Lithography, photography, photoacoustic lithography, luminography. The answer is lithography. So basically, in the lithography, you have a stamp or something, So basically, it is a very old process. It is derived from the Greek word lithos, which is stone, and graphy means painting. So basically, you use the stone, you dip an ink over it, and then you stamp it on wherever you want to do, and then you get the image. So that is what lithography is. Photography, everyone knows. Photoacoustic lithography is basically you use photoacoustic energy to do the lithography, and luminography is basically light. You are using light to do the printing. So basically, it looks like a projector or something. The seventh question, basically, dash are made up of semiconductor nanoparticles and are luminescent. So basically that they emit light. So 1D material, 2D material, quantum dot probes, or 3D probes. So the answer is quantum dot probes. So this is one example. So here they are using wolfsonite nanoparticle. So uh, here they are using like blue. Depending on the size, you'll see different type of absorbance. So you will get blue, green, red, different types of colors based on the size. That is why the answer is quantum dot. The eighth question is chemical co-precipitation method involves mixing two different salts with precipitation in an aqueous solvent, especially acid, base, inert gas, metamaterials. So the answer is base. So you can see the process here. You are using ferrous sulfate and ferric chloride, and you are using the water, and then you are using ammonia so as to actually have the process going forward. So the answer is base. uh, so the ninth question, the main difference between graphene oxide and the reduced graphene oxide based on the presence of dash and its conductivity. So it's this is the sort of diagram of graphene oxide. So from the you can see that there are a lot of oxygen groups on the surface. So that is the thing. So in graphene oxide, there is a lot of surface oxygen. When you remove the surface oxygen, you get reduced graphene oxide, and that is a very high conductivity. Then the tenth question, synthesis of near infrared absorbance nanomaterials has emerged in biological applications since the biological tissue exhibit low absorbance in the region, high absorbance in the region, no absorbance in the region, extremely high absorbance in the region. So the answer is low absorbance in the region. So any questions? In case you have questions, you can unmute yourself and ask. Since nobody's there in the session, we'll call it a day. And I'd like to thank you for your participation, and we'll see you next week. Thank you.